is you.
Whoa. Okay.
This is your screen. You're live on YouTube.
Live on YouTube.
Oh, God. Oh, God.
Is it the Giant's Causeway? Is that what that is?
I cannot answer.
Change the date on that too.
It's Ground Math Day. Right. It should be live after that.
Just another Factor Monday.
Ooh. Okay. Yes, you're on.
Thank you.
Thank you. Whoa.
Whoa. Yay.
Let's skip the boy.
Okay. Love you. All right, guys, we're here factoring. All right, so welcome to Math Monday. I know it's a little bit of a different night, but that's okay because this is the night that I had free. So we are live on Monday right now. So if you have any questions or any concepts or anything that you want to get into, pop it in the chat and we will talk about it. But in the meantime, let's factor some polynomials because you guys know I love factoring polynomials. And it's what I'm doing in my class right now. So might as well start making an answer key. All right, so take a look at this problem and see what you can do with factoring. Yeah, so factor 5, then difference of squares. Good, I'm glad that you noticed there's the difference of squares, huh? Jack, you just had a test on this. How did it go? Hopefully it went well. Easy peasy. All right. That's not a bad way to feel about it. That's awesome. All right. All right, so the first thing that we're going to do, so factoring of anything, factoring is just rewriting an expression or like part of an equation or something like that as things multiplied together.
Okay.
Yeah.
Good.
Nobody's told me otherwise, so. So what we're going to do is we are going to, we're going to factor out, the first thing we want to look for is the GCF, which is the greatest common factor. Okay, so the GCF here is something that everything's divisible by. So what's everything divisible by is a 5. So I can go ahead and I can take a 5 out of here. Now when I take that 5 out, I'm left with r squared minus, let's see, 80 divided by 5 is 16 s squared. Okay, so that 5 is just going to hang out there. I can't just get rid of it because this is an expression. If it were an equation, I could just divide everything by 5, but I can't do that. So now I'm looking at this. Now when you're factoring, when you first learn how to factor, you're really just kind of writing out like, you know, 2 things that can multiply together to make this other thing, or 3 things, whatever it is, right? You start pretty simple. And usually there's only just like 1 step, maybe 2. When you get into more advanced factoring like this, like with an algebra 2 level, you have to constantly be looking like, can I do more? Can I do more? Can I do more, right? Okay, so now when I look at this, I've got r squared minus 16s squared. So the fact that these two terms are both perfect squares means that I can use something called the difference of squares. Okay, so the difference of squares is where when you have these two perfect squares that are being subtracted, you can rewrite them or you can factor them. So my 5 is still going to be out there. Okay, now my square root of r squared is r. My square root of 16s squared is 4s. So these are my two terms, my r and my 4s. Now, what's going to happen is I'm going to make 1 plus and 1 minus. Okay? So right here, now with the plus and the minus, it doesn't matter the order. Like this could be r minus 4s and r plus 4s. The main thing that you're looking for is one of these has to be positive, one of them has to be negative. And this right here has to be a negative, right? That has to be a subtraction. Yep, it can be minus and then plus, doesn't make a difference. Okay, so we've got r squared minus 16s squared. So the reason this works out is because if I were to multiply these all together, okay, the 4r's would cancel out, and then you're left with that same thing. So you've got a plus 4s minus 4s, that's a negative 16s squared. Okay, so this is where you're factoring. This is called difference in squares or difference of squares. Okay. So let's keep going. Okay. Yeah, so the square root of 16s squared is 4s. So the difference of squares, let me write out what the formula is. Okay, what the difference of squares actually is. So the difference of squares, oh, I don't like this marker. Okay, so the difference of squares. So difference of squares is when you have two perfect squares that are being subtracted. Okay, so when you've got a squared minus b squared. Okay, I actually meant to write this further over. So if you have something that's in the form of a squared minus b squared, okay, what this can be factored out to be is you take the square root of a squared, you take the square root of the first term, that becomes your a, the square root of the second term, and that becomes your b. Then you're going to have a plus b times a minus b. Or it can be a minus b and a plus b, as long as these are two, that they're the exact same except for that plus and minus. Okay, so if I were to have 4x squared minus 49, okay, and I asked you to factor this. Exactly, so they have to be a plus and a minus, so the b term cancels when you multiply these together. Okay. All right, so 4x squared minus 49. So I've got my subtraction, great. And 4x squared is a perfect square and 49 is a perfect square. So my square, so a is my a term is going to be the square root of 4x squared. Square root of 4x squared gives me 2x. So my a term is 2x. My b term is going to come from the square root of my second term, which is 49. That's going to give me 7. I know it's plus or minus 7, but in this case, we just pay attention to the positive one, okay? All right, so my a is 2x and my b is 7. Now, once I have these two figured out, I just plug them right in. So it should be a plus b. So I've got 2x plus 7 times a minus b, which is 2x minus 7. Okay. But again, the order of this doesn't matter. Okay. Oh, thank you. It's, yeah. I'm very proud of my handwriting. Thank you for noticing. All right. So now that's the difference of squares. So now you can see when we look back at this one, got a little mushed. Okay. When we look back at this one and we see r squared is a perfect square, and we know 16 is a perfect square and s squared is a perfect square. So the square root of r squared is r. Square root of 16s squared is 4s, because 4s times 4s is 16s squared. Okay. Woo! You knew exactly where we were going. I can't see your name. Shiz, Mom. I think difference of a cubic. Yes. Oh, and we are going to do factoring trinomials too. We are going to do as much factoring as we need to. Okay, so that's the difference of squares. There's also, you can use cubes. Okay, so now with cubic equations, let's start with the difference of cubes. Since we just did difference of squares, let's do difference of cubes. Okay, so the difference of cubes, so the only difference is that you're still looking at two terms, but now they're cubes. So now we're looking at these cubes. So still the same idea, okay? So we still break them down into A and B. So the cubic root of my first term, that's going to be my first one, right? So what this becomes is this becomes A minus B times A squared plus AB plus B squared. So let's see something really quick. Okay, great. All right, so let's take a look at one of these. So we're going to factor here. So we've got, let's do m cubed. So m to the third power minus 343n cubed. Okay, so let's factor this. So spam. No, it's not. It's not 2ab. I think what you're thinking of is if you've got, when you're looking at a plus b times a plus b, that's going to be when you're just like squaring a binomial. It would be a squared plus 2ab plus b squared. I think that might be what you're thinking of. So AB just means you're multiplying your two terms together. Okay. All right, so here, I know this is a difference. Now these are both cubes. And again, this, recognizing all these things like sum of cubes, difference of squares, all that kind of stuff, it takes some time, it takes some practice, okay? There's a reason why teachers give you a whole bunch of practice problems. It's because you just kind of get used to coming across all of these things. So to find my A value so that I can just plug it in, right? So to find my A value, A is going to be my cubic root of m cubed. Okay, now the cube root of something cubed is just going to be that something. So that's going to be m. Okay. And then my B value, I know this is kind of squishing together, but is going to be the cubic root of 343n cubed. Okay, and if we get out our calculator and we look at the cubic root of 343, it is 7. So our B value is 7n, because the cube root of n cubed is n. Okay. Oh my gosh, Blunder Fisher. Okay, that one problem No. No, and I think there was something wrong with the setup, or it was just a devious, it was just an evil problem. Yeah. So the method was correct. The method that we were doing was correct, but it was just so long that it was going to take that it was just kind of a diabolical problem. Okay. Thank you for bringing that up. Okay. So now I've got my A value and my B value. So now I just plug them in. Okay. So A minus B. I'm going to get this. I'm going to write it in blue. So A minus B. So that's going to be M minus 7n. A squared is going to be M squared. A times B is 7mn. And then B squared is 49n squared. Yes, the 5 pages, and then I surrendered. I was like, this is for the birds. I'm done. So once you know your A and B values, and you have this formula, it's really easy to factor these out. Okay, so that's difference of cubes. But there's also the sum of cubes, which again, I mean, it's not, the sum of cubes is basically the same thing, except this is a plus. So this is A cubed plus B cubed. So this is A plus B times A squared minus AB plus B squared, but it's basically the same idea, right? You still do the cube root of each of those things, blah, 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 blah. Let's get into trinomials. Those are way more fun. Okay. Ooh, and then 4 terms. Oh. Okay, let's start with we'll do a couple of trinomials and then we'll get into factoring by grouping, because what you can do is you can keep going like on and on and on. You've got to factor and factor and factor. A to the 4th minus B to the 4th. Ooh, Marilla, that's a really good question. So let's go back to that. So A to the 4th, so you've got A to the 4th minus B to the 4th. Okay? So when you see something with 2 terms like this, you go, okay, you should be thinking like, all right, I'm going to be looking for like difference of squares, difference of cubes, sum of cubes, all of those things, okay? Now here, because these 2 exponents are divisible by 2, okay, I can use difference of squares on this. Okay, so this is going to be difference of squares. Okay, and the difference of squares, remember, so we've got A to the 4th, B to the 4th. So I'm going to take the square root of the first term and the square root of the second term. Now this gets a little bit confusing because we always use A and B for like your formula, right? But let me grab my difference of squares. Here we go. Okay, so here's the difference of squares formula. All right. So here, A to the 4th, this, it's going to be like this A versus this A. Okay, so here's what I'm going to do. Actually, you know what I'm going to do? I'm going to change these to X and Y, just so it's a little bit easier to show, but the process is still the same, right? But just so it's a little bit less confusing. Okay, so now we've got X to the 4th minus Y to the 4th. You can definitely use substitution with the U value, absolutely. Okay, but so X to the 4th and Y to the 4th. So to figure out my A value, A is going to be the square root of X to the 4th, which the square root of X to the 4th is X squared. My B value is going to be the square root of Y to the 4th, which is Y squared. So now once I figure this out, now I've got this is going to be x squared plus y squared times x squared minus y squared. Okay. So that is your difference of squares. However, what do you notice? Remember, factoring, you've got to keep going until you're done. We're not done yet. Exactly. So Olivia, it can only work on the second set of parentheses, right? We don't have a sum of squares rule. We have a difference of squares rule. So this one is what it is, x squared plus y squared. Great, that one's done. But this one, we can go again. So my a value would be x and my y value would be b. Yeah, I think I said that right. My a value would be x and my b value would be y. Anyway, so this just is going to drop down again. So x squared plus y squared, that stays the same because I can't simplify that, or I can't factor that anymore. And then x squared minus y squared, I can factor that again and have it be x minus y times x plus y. Okay, and now I go back through and I double check. Can I factor anything else? Nope, I can't factor anything else. So that is my answer. Okay, yeah, there's always a different, there's another set. Can't you factor out x and y in the sum of squares? You can't factor out the x and the y because they don't both have an x and a y. Okay. But let's look at a problem where we would factor something out. Okay, so let's look at this one. Let's do, well, we did that first one. See, this is really good. Okay, actually, I'm gonna work this out with you guys. Okay, so let's look at another one where we can factor some more. Ah. All right, so we have 10w to the 5th minus 10w. And we're factoring. So Mariana, try to describe the math problem in the chat, because I don't really have a way to check that out right now. Yeah, Micah, so factoring you usually learn in Algebra 1 or even pre-algebra in middle school to some extent. This level of factoring that we're doing right now is a bit more like Algebra 2, so like sophomore, junior year. Okay, so I can factor out, I've got a GCF. Okay, I've got a GCF of 10W because they're both divisible by 10W. So I'm going to take out that 10W. And in the parentheses, it's what's left behind. So this is going to be W4 minus 1. Okay, W to the 4th minus 1. Okay. Now we go, oh, this is a perfect square and this is a perfect square. So let's difference of squares then. So we've got 10W still just hanging out here. I can't get rid of that 10W because it's still part of the factoring. Okay. Oh, how did I get 1? Because 10W divided by 10W is 1. So when I take out the GCF, it's sort of like dividing those things by that GCF. So if I distributed this back through, I would get this back up here. Okay. John, we will practice grouping. Yep, we'll get to that. Okay. So difference of squares, I've got W squared plus 1 and W squared minus 1. Okay, are we done? No, we are not. What do we have now? See, and this is working out great because I had this, I forgot to do the second. I don't think I finished that one. I think I got interrupted. We are not done yet. You're right, because what have we got? This one is set. Obviously, this one is set. This one is set. Difference of squares. One more time. One more time. We've got 10w times w squared plus 1 times w plus 1 times w minus 1. And now we look through, and there's nothing else we can do for it. Okay. All right, so let's look at some grouping here, okay? So grouping is how we're going to factor with 4 terms. We're burning through the boards today, guys. All right. So we've kind of gone over all of those different ways of doing this, but now we're looking at this. Okay. I know, Josh, it's Math Sunday. This is Math Monday. It honestly, like my schedule has been changing so much this year that we just kind of go live whenever we can. But yeah, this is primarily Algebra 2, but you'll see this also in pre-calc a lot of times too. All right, so we have 4 terms here, right? We have 1, 2, 3, 4. So when we have 4 terms, we are going to do factoring by grouping. Okay, where we're going to kind of split this into 2 groups. Okay, and I'm going to take out the GCF of this group and the GCF of this group. Okay. So we're going to take x cubed plus x squared. We're going to look for a GCF, and in that case, it's x squared. So I can take out x squared, and what's left behind is x plus 1. Okay. Over on this side, I'm going to take out a negative 4 because they're both divisible by negative 4. And what I'm left with is x plus 1. So factoring by grouping is one that you usually learn when you're first learning how to factor trinomials and polynomials and things like that. So this is something that you may see in middle school or Algebra 1 or your first year of high school math, things like that, okay? The important part is that these 2 things that are in the parentheses, these need to be the same, okay? The reason they need to be the same is because that is one of your factors, is x plus 1. Okay, your other factor is x squared minus 4. So x squared and minus 4, that's one factor. And then x plus 1 and x plus 1. So if they're not, double check that you pulled out the GCF for sure from both of them. And if it's not, then you can't factor it. Okay? All right, are we done yet? Nope, not yet. Right? We've still got, look, x plus 1, that one's done, right? We can't factor that anymore. But look at this x squared minus 4. We got a difference of squares right there. Right? We've got x squared and we've got 4. So now this becomes x minus 2 times x plus 2 times x plus 1. So x minus 2, x plus 2, and x plus 1. Now are we finished? Yes, now we are finished. Okay. Sarah, what do you mean grouping with a trinomial and a monomial? Isn't a variable without a number equivalent to 1? So it's not equivalent to 1, but if it's a variable without a number written, it's understood that there is an invisible 1 in front of it. So it's not equal to 1, but it does mean that there is a 1 as the coefficient. Okay. All right. Okay, so factoring trinomials actually means grouping a perfect square trinomial from 4 terms. A perfect square trinomial from 4 terms. So if we have okay, hold on, let's see. Okay, so let me see. Is this what you're asking for? Grouping a perfect square trinomial from 4 terms. It is like another language. It's a beautiful language. Okay, so let's see. Oh wait, no, this is not right, guys. Hold on. 2x cubed, 8x squared, 2x, and 4x minus. I was wondering why that didn't seem right. X squared. Okay, here, this one. Let's try this one. Let me see, because this will give us a perfect square. Okay. Ooh, long division, yes. Yeah, I'll do long division. Okay, yep, John, we can definitely do long division of polynomials next. We're just having a polynomial day today, huh? Yeah, once you learn synthetic, you just toilet brain that long division, huh? Multiplying and dividing rational expressions. Penny, can you give me an example of what kind of problem you're asking about so I know like what kind of level you're on? Oh, Tim, what is my academic background? So I've been a math and science teacher for over 20 years, and I have a degree in biochemistry, and I am currently working to become a board certified teacher, national board certified teacher. So I've taught everything from like 5th grade science and math all the way through like AP biology and AP or anatomy and physiology and all that kind of stuff. Okay. Yeah, so we'll do division of polynomials right after we finish doing this. Okay, so we've got 4 terms. Well, first of all, before we do anything, we check for a GCF. No, there is no greatest common factor, right? There's no greatest common factor here. So now we can go into factoring by grouping. So first I'm going to look at this top half. So 2x cubed plus 5x squared. So I can take out an x squared from there. So x squared times 2x plus 5, right? Is this right? I don't think I did this right. 2x cubed plus 5x minus 4x minus 12. I don't know. This one might not work, guys. Minus 4 times x plus 3. Did I, in my rush to try to get one of these problems, let me see. 2x cubed plus 8x squared plus 8x minus 3x squared minus 12x minus 12. That's what I'm thinking, but 2x cubed plus 5x squared minus 4x minus 12. I got the same thing again. Interesting. Well, let's try it with a 6. I don't know why that's... Let's try it with a 6. Let's just see where it goes. Okay, this is why you don't rush, kids. Okay, so then we can take out the 2 from... Oh my God, this is turning into a disaster, guys. Okay. All right, so we can take out the 2. Let's see if this one works, because this is not what I had in my notes, but I did very scrolled 3x squared minus 2x minus 6. Okay. All right, so now we keep that 2 out. Now we can factor by grouping. So we've got x squared times x plus 3, and then minus 2 times x plus 3. I'm gonna change this to a bracket. Yeah, I mean, I guess this will work. I mean, this will work, but it's still kind of annoying because it's not working out how I wanted it to, but that's okay. All right, so then it's 2 times x squared minus 2 times x plus 3. It's not giving us that perfect square because right here, that x squared minus 2, that's not going to be that's not a perfect square. That's not going to be, yeah. The equation is, oh, I might have. Yeah, it shouldn't be minus 12x. Okay. So this is how you would factor that. All right, let's move on to dividing polynomials. Okay, so dividing polynomials. Woo woo. So long division of polynomials. So long division of polynomials actually kind of follows along with the classic algorithm of long division before. Okay, wait, Daniela, I'm having trouble with 3 times m minus 2 minus 4. Okay, wait. Okay, Daniela, let me answer your question really quick because this is okay. And then we'll do long division of polynomials. Sorry, guys. M minus 2 minus 4 is greater than or equal to 7m plus 14. Okay, so this is an inequality. So when you're solving these inequalities like this, you're going to solve it just like an equation, okay? Exactly the same as an equation. The only time that you need to do anything with this symbol that changes it is if you multiply or divide both sides by a negative number, okay? So then it would flip directions. But other than that, you just solve it like a regular equation, okay? Like a regular old linear equation. This pink marker. All right, so I'm going to distribute that 3. So I've got 3m minus 6 minus 4 greater than or equal to 7m plus 14. I'm going to keep simplifying on both sides just by combining those like terms. So now I've got 3m minus 10 is greater than or equal to 7m plus 14. Going to add 10 to both sides. So now I've got 3m is greater than or equal to 7m plus 24. Okay. Subtract 7m, because again, just like an equation, we want to make sure that all of our variables are on one side and all of the other stuff is on the other. So now I've got negative 4m is greater than or equal to 24. So my last step is I'm going to divide by negative 4. Now remember what I said, the only time you have to switch directions of the sign of the symbol is if you multiply or divide by a negative number. So that just happened. So now I've got m is actually less than or equal to negative 6. And that's going to be my solution. And if you need to graph this on a number line, right, all you really need to mark is just negative 6. It's going to be a closed circle because it includes negative 6. And it's going to be everything to the left of it. And that's it. Okay. Let's see. We are not really going to get into AP Chem, but I'm sorry that you're confused on the kinetics. Ooh, AP Calc. So guys, we really stick sort of between like the pre-algebra to algebra 2 pre-calc concepts. But if you have a specific question about any sort of calculus concepts or anything like that, put them in the chat because we have a really good community here and everybody can jump in and help you out with that. I do trig. So we're gonna do some polynomial stuff right now. We're gonna do some long division of polynomials. Okay, so long division of polynomials is, let's start out with, let's see, we'll do 2x cubed plus x squared minus 6x minus 8 divided by x minus 2. Okay. So you use this if you are trying to solve polynomials or if you're trying to graph polynomials and they aren't necessarily factorable. Okay, so this is a way to be able to kind of break them down a little bit further if they're not so easily factorable. Or if you know one root and you're trying to figure out the rest of them, things like that. This is not 7th grade math. The inequalities that we did before, that's like 7th and 8th grade math, but this is not 7th grade math. Okay. So we're gonna do this the long division way. I know synthetic division is easier and it's simpler and it's faster and it's more efficient. I get it, but the question was about long division, so that's what we're doing. Okay, so long division of polynomials, just like if you had like 15 divided by 3, right? So this one here is gonna go inside the house. We've got 2x cubed plus x squared minus 6x minus 8. Okay. And then outside the house is going to be x minus 2. So this is how I'm going to set it up. Now, just like the algorithm for long division, okay, I'm just going to be looking at, okay, this times this down here, right? And then subtract. This times this down here, subtract, okay? So when you're looking at this, hold on, let me see. Okay. Okay. So I'm just going to be paying attention to this x and like what the next term is. Okay. So Ballad, we'll try to do the adding and subtracting them. Yes, for sure. But the big thing, just if you're, I can't tell if that's Ballad or Bella. Sorry. Yeah, Tim. Okay. Oh, thank you. Okay. Look for combining like terms, and you can add and subtract things, but we'll get to that. Okay, so I'm looking at this first term here, and I'm looking at this first term here. Now up here is what this times this is going to equal this. I know there's a lot of like thises and that's, but just bear with me. Okay, so x times what will give me 2x cubed? Or I can think about 2x cubed divided by x. That's going to be 2x squared. Okay, I'm shifting it over. Yes, Fabian, this is long division. So I'm shifting it over just because like that, it keeps it lined up, and you'll see why. Okay, so now I do 2x squared times x minus 2. So again, I'm not really paying attention. I'm not letting this -2 really dictate what I'm trying to do. It's just along for the ride. So I have 2x squared times x. That gives me 2x cubed. But then I also have to do this -2. So minus 4x squared. Okay. And now I subtract. Okay, it's best if it cancels out. So Fabian, it actually has to cancel it out because otherwise it's not going to work. Okay, so it's got to cancel this out. So 2x cubed minus 2x cubed, those go away. X squared minus -4x squared, that gives me 5x squared. Okay, and now, just like regular long division, I bring down the next piece, which is minus 6x. But I'm not going to pay attention to that minus 6x yet. Okay, so it's not 4x cubed. It's 2x cubed because it's minus 2x cubed. So those cancel out. So that gives me a 0. Okay. Now -6x comes down. So now I'm going to look at this term and this term. So x times what gives me 5x squared. Okay. So this is going to be plus 5x. The reason for that is because 5x times x gives me 5x squared. Okay. So the -4x squared came from 2x squared times -2. That brings that down. This is subtracting. So x squared minus -4x squared gives me 5x squared. Okay. So now we've got, let's see, I lost my place. Okay, 5x times x, which is 5x squared. 5x times -2, which is -10x. I think somebody was asking for brackets maybe around this, probably. That makes a little bit more sense. Yeah, that works. Okay. So now 5x squared minus 5x squared, those cancel out. -6x minus -10x, that's going to 10x, that's going to be -6 plus 10, which gives me 4x down here. Okay. And now I bring down the -8. Now this is one of those moments that is just, It's the beautiful, beautiful thing. Okay? So 4x and x. So x times what gives me 4x? X times 4. So I do a plus 4 here. So I do 4 times x, which is 4x. 4 times negative 2, which is negative 8. I'm going to subtract all of those. Oh, look at that. 4x minus 4x, 0. Negative 8 minus negative 8 is 0. There is no remainder. So this is my solution. Okay. So instead of factoring it, I was able to divide it. Okay. I love doing these things. Okay. Yeah, it's a double negative. So it's not whether you're doing it right or wrong if it's going to have a remainder. You can have a remainder. There are remainders in this. It's just like I tell my students all the time, like a decimal or a fraction for an answer doesn't mean it's wrong. A remainder doesn't mean it's wrong. It just is what it is. Okay, so it's just going to kind of be whatever it is. Okay, let's see. So if there was a remainder, it would just be like plus, 3 over x minus 2 or something like that. Okay. Yes, synthetic is easier, but again, the question was specifically for long division, okay? All right. Somebody asked for, adding and subtracting polynomials. Okay. So when we're adding and subtracting polynomials, we usually say that this is for like simplifying, okay? All right, so if I have, say y plus 4y squared minus 3 minus 1 plus 2y squared minus 5y minus y cubed. Kind of ran out of room. That last one is a y cubed. Okay. So we're going to simplify this by adding and subtracting them. Okay. So some people prefer to like go through and distribute this negative where you would just kind of flip all the signs. So we can go with that. That's fine. For this one, that's fine because it's not in standard form. It's not in like standard notation. So I don't have anything to distribute through this. So I'm just going to leave these. I'm just going to drop the parentheses on this. Okay. And then it's minus all of that. Okay. So I've got negative 1 minus 2y squared plus 5y plus y cubed. Okay. Yeah, so Laura Smith, that last problem that we did, it could be solved by a couple different ways. But again, the specific question was specifically about long division of polynomials. Okay. All right, so now I've got all of these things, I've got the negative distributed and all that. So now what my goal is I'm going to organize these and kind of group them by being like terms. Okay. So like terms, we're getting them all together. We're looking for what makes a like term is it's got to have the same variable to the same power. Okay, and when we write something in standard form, we want to write from the highest degree to the lowest degree. And the degree is just the value of the exponent. Okay, so my highest degree here is y cubed. That's the only y cubed that I have. So that's going to be my first term. It's just y cubed. And then I like to kind of cross them off, especially when there's a bunch of them. I just kind of cross them off as I go. Okay. So after 3 comes 2, right? So y cubed, next is going to be all my y squared terms. So I've got 4y squared minus 2y squared. If I put those together, I don't change the exponent, I only change the coefficient. So that's going to be plus 2y squared. So I've got 4y squared minus 2y squared. 4 minus 2, 2. All right, now I've got just the y's. So I have 1y here and 5 y's here. So I add those together and I get 6y plus 6y. Okay, and now for my numbers, I've got, let's see, minus 3 and minus 1, and that's it. So that's minus 4. There we go. So that is my solution for adding and subtracting those polynomials. Okay, thank you, sir. Have a good night. So you can do synthetic division when A isn't 1, but you have to do, so you have to sort of like divide your second piece by that A value. So if it's like 2A minus 3, what you would actually put, so if you were setting up a synthetic division problem and it was 2A plus 3, what you would actually put over here would be negative 3 over 2. Because you are technically using that root, that 2A plus 3, you're using that as a root, which would be negative 3 over 2. Okay. All right, Jasmine, how to do probability? You gotta be a little more specific. There's a whole lot of probability out there. Okay. Anything, let me double check if there was anything that I missed. 2 negatives equals a positive if you are multiplying or dividing them, yes. Or if you're adding, well, no, not if you're adding. If you're subtracting them, it could. Okay, let's see. All right, let's see. I see a lot of logarithm answers or questions. This is not calc. No, this is probably this could be like you might see something along this lines in like pre-algebra, like middle school, or you may see it in like high school for sure. All right, let's talk about dividing polynomials by a monomial. Okay. All right, so 30 C5 D4 minus 36 C3 D2 plus 6 C3D divided by 12 C squared D. Okay, so let's simplify that through. Xavier, I'm right here. I've been here the whole time. Oh, John, the slip slide method for factoring trinomials. We can do that next. And then that might be all we have time for. Malik, I am doing this literally like from our notes for tomorrow. So yes, we are doing this in class. Malik, you missed that in my intro. I was like, I'm just gonna go ahead and prep for class tomorrow. Okay, we did the whole other unit too with factoring and everything, but okay. So when we're looking at this, okay, a major thing is we're going to look at the numbers, and really you're kind of looking at this as like simplifying each individual term. Okay, so I'm going to write this. I'm just going to split them up. So we've got 30 C5D4 over 12 C2D minus 36 C3D2 over 12 C2D plus 6C3D over 12 C2D. Okay. So you can think of it this way. Now you do not have to like go through all of this. You can look at these individually, but this is basically what you're doing. Okay, so we're dividing, this is dividing a polynomial by a monomial. Okay, so 30 over 12 is going to reduce down to 5 over 2. So we've got 5 over 2, and then c to the 5th over c squared. I'm going to have 3 of those c's, and then d4 over d, that's going to be d cubed. Minus 36 over 12 is 3. There's 1 c and 1 d there. And then plus 6 over 12 is going to be 1/2. Just c, right? Yeah, just c. Okay, so that would be simplifying it down. All right, so the last problem of our show tonight. We're going to go over the slip and slide method of factoring. I love doing this. Now, it is sort of a cheat code. I know this, but man, it's a really handy cheat code. So when you're factoring this, okay, again, we're going way back to the very beginning with factoring. Okay, I've got 3 terms, or I'm sorry, I've got 3, I've got 3 terms. What am I talking about? I've got 3 terms. These are going to be, this is going to be factored down to be 2 binomials. Okay, so the slip and slide method is where you take this. This really only applies when you have a number in front of here, okay, in front of that x squared. I'm going to go down here. I'm going to multiply 8 times negative 5. And I'm going to rewrite this as x squared minus 6x minus 40. Okay. Now what I want to do is I want to figure out 2 numbers that multiply to negative 40 and add to negative 6. Since this is negative, the signs are going to be different. Okay, so if I think about my factors of 40, I have 1 and 40, I have 2 and 20, 3, 4 and 10, 5 and 8, 6, no, 7, no, 8, back there. Okay, so when I'm looking at these, which of these sets of numbers multiply to negative 40 and add to negative 6? It's going to be 10 and 4. More specifically, it's going to be negative 10 and positive 4. Because negative 10 times positive 4 gives me negative 40. Negative 10 plus 4 gives me negative 6. Okay, so now I'm going to split this up, and I've got my x plus 4. And this part, it doesn't matter if it's x plus 4, then x minus 10, or x minus 10 and x plus 4. That order of those 2 things doesn't make a difference. Okay. Alexis, is that the homework that I gave you today? Number 13? Oh, wait, I said you don't have to do 13 and 14. 13 and 14 don't do unless you want to learn how to solve quadratics, which you can. But yeah, 13 and 14, you don't need to do those. Okay. All right, so x plus 4 times x minus 10. So now, but remember, this, if we multiply these together, it's not going to work. Yeah, Alexis, spread the word. 13 and 14 you don't need to do because those turn out to be quadratics. Don't worry about it. We'll revisit them later. Okay. Oh, shoot. Hold on. I'm going to do my little puzzle piece. All right, so now, since I multiplied by 8 up here, I need to now down here divide by 8. Okay, I need to kind of undo that piece that I did. Okay, now x plus 4 over 8, that becomes x plus 1/2. And x minus 10 over 8, that becomes x minus 5 over 4. Now what we do here is we do a little bottoms up. Okay, so whatever's on the bottom becomes the coefficient for the x. So this is now 2x plus 1 times 4x minus 5. And that is the slip slide method. And if you multiply these back together, right there. Okay. So Lorsman, there are other ways, but again, the question was specifically asked to go over the slip and slide method. Okay. All right, guys, have a wonderful evening. Thank you for, oh, Ethan, go over to YouTube. We did dividing polynomials. We did long division and dividing by monomials. So you can go over to the other place and you can rewind it. All right. Have a wonderful night, guys, and have a great week. If you have anything specific, you can always send me an email or send me a message or whatever, okay? All right, have a good night. I'll see some of you tomorrow.